Greetings, Earthlings. Well, now that we've got the terminal working, we can actually start looking at writing some code to run on this Nova 445 computer. All the code we've been running so far has been running out of ROM, but it would be nice to be able to load code into RAM, which is over here. That's the RAM. And run it from there. So, oh, I know what you're thinking. Front panel with the switches and the blinking lights and everything. And yeah, no, not yet. We're going to use what we got, which is the terminal. Except it'll probably be a laptop because we'll do a binary load. I've written what we call a monitor program, ROM Monitor, which allows us to examine and modify memory. It also has the ability to load programs over the serial port in Data General's binary loader format. Now, I don't have any such programs right now. If I had a copy of a paper tape of some Data General code, that could load, but I don't at the moment. And it also has, I've also written code to boot off of a hard drive, but we have no disk emulator yet, so we're stuck with just entering it on the terminal. But we can demonstrate that. We'll power it up here. And I don't know how well this is showing up on camera 2 there. But we have, so let's run through the operations. We can examine a location by typing the octal value of the location and a slash. It will give the current contents, and then return, we'll just leave it as it is. Or I can modify it, type a new value in there, okay, and then if I come back and look at it again, we can see that hopefully it has changed. If I want to continue on to the next location, I press line feed instead of return, and that will show the next location. And that continues on. You can see I'm running out of paper here. That's what that red stripe means. But that's okay, I've got more. Look, I've got more. But there's at least a foot left or so we'll just keep using it. And return when you're done there. So I did line feed, and then return. So that was location, 2? So we go back and look at location 2. We can see that it did get modified to 111. Okay, so that's how we examine and modify memory. What else can this do? Let me see if I remember. I've got a cheat sheet here. Oh, well, we can run starting at a specified location. We'll get to that because I'm about to enter some code in. Then there's 2 other commands. L would be load from the terminal, and that's going to require the laptop in a binary formatted program, which I don't have right now. So that's a future video. And B is boot from hard drive, and again, there's no hard drive, so L and B, if I tried those right now, they would just hang, which isn't very exciting. So let's go and put in a program. I'm going to make it echo characters typed on the terminal here. So I'll start at location 1000 octal, 1000 octal, and the first is a 63636110. Line feed. That's, by the way, that instruction is skip if done non-zero, TTI, which is teletype in. This is jump dot -1. So the done flag will be set to 1 when there's a character waiting. So that's just going to be in a tight loop waiting for a character to get typed. And we go 60610. That's DIAC, data in A, and clear to accumulator 0, the TTI. What that means is read in what's in the TTI's A register, which is that character which just got read in, and clear the, busy and done flags. We're not using the busy in this one. So clear the done flag, and so be ready for the next character to be typed. That was 60610. Next is 63511. 63511. This is waiting for the teletype out. We call this a teletype even though it's a silent 700, but TTO is the device name. Teletype out. Skip if busy is 0. So busy is 1 when it's not ready to receive a character. Busy is 0 if the terminal is ready to receive a character. It would set done to 1 when it's actually finished sending that character. We don't care about that for this purpose. It's just as long as it's ready to receive it, we're going to give it to it. But in this case, skip only if it's ready. And 777 is jump dot -1. So that's going to sit in a tight loop waiting for it to be ready. And I have 61111. That's data out A and start accumulator 0 to the TTO. So data out A says send the contents of the specified accumulator, which in this case is accumulator 0, to the A register of the TTO, and that is, I think, the only register that's implemented for the TTO. It's basically the parallel input to the UART. And S is start, which tells it that it's got the character available and that it should start printing it. And then we'll jump back to the beginning of the loop, which is A772. Okay? So now if I say 1000 G, that is now running. And if I hit return line feed, it's not running. So what did I do wrong? Let's see. Did I get them all in there? I don't think I got all the... Oh, no, right up here. I didn't hit line feed. Okay. So, we'll reset. And we're going back to 1002. And that is 60610. Line feed. 63511. Line feed. 777. Line feed. 61111. 4 ones. Line feed. 772. Return. Okay. That looks better. 0, 1, 2, 3, 4, 5, 6. I actually forgot line feed twice up here. Yeah. Okay. 1. But this shows you that it's really running the code, because now when I say go and I hit return, it's going to do the return. It's going to do the line feed. And I say hello world. Return line feed. Line feed. When in the course of Unon events and so, and that among these are life, liberty, and the pursuit of happiness. So anyway, that's a start. That's the monitor program running, and the next step is probably to modify my assembler, which has been producing hex files for the ROM programmer, and make it able to produce the data channel binary files, which I can then load with the L command. Like I said, that'll be a future video, and then we'll move on to other things. At some point, we'll implement a disk emulator, and we'll do the boot from disk, but that's probably way down the line. First thing is playing with actually writing code without having to burn ROMs every time. Of course, I do still have to load it over the serial port, but hey, I can live with that.